Emostel.
Hello, this is Emostel Academy and you are welcome to Emostel Academy. In this course, MTH103 Elementary Math 3, I'm going to really take you through a whole lot of things, and I promise it's going to be a very beautiful journey all the way. I'll try my best to keep things simple, and I just promise that you're going to enjoy it. All right, so we're going to start with the topic vector. And in this video, I'm introducing you to vectors. And part of the introduction, I'm going to just explain briefly quantity, magnitude, unit, scalar, and vector. All right, so without much ado, let's just get into it. What are quantities? Well, in mathematics, physics, and practically everything else, a quantity is anything that can be measured. All right. Okay, I can measure my height. You can measure height. You can measure temperature. You can measure mass. You can measure weight, and all of this stuff like that. So anything, just in normal, plain, simple English, a quantity is anything that can be measured. All right. And so whenever you take the measurements of a quantity, the value of that measurement is what we call magnitude. Are you getting me? So if I measure the mass of this pen, the value that I get, the numerical value of that measurement, okay, maybe this marker weighs 10 grams. All right, so that's 10 is the magnitude, and then the grams that I put after it is the units. You get that? So the name that is given to the measurement, or the name that is given to the value of the measurement, is what we call units. So while quantity is anything that can be measured, so the moment we measure that thing, the value, the numerical value we get for the measurement is magnitude. And then the name given to that numerical value or given to that measurement at that instance is what we call the units. So this biro, it weighs 10 kilogram. All right. Okay. What did I weigh? What is it? What is the measurement I took of the biro? I took the mass, the measurement of the mass of that biro. This mass is what we call is a quantity. The mass of the biro is a quantity. All right. So the numerical value of the measurement is the magnitude, and this kilogram that I put after the measurement, all right, the name given to the measurement is what we call the units. All right. So that is how it goes. Okay. It's the same everywhere. And then that takes us to the two types of quantities that we have. We have the scalar quantity and the vector quantity. A scalar quantity is any quantity that has magnitude but no direction. So which means we can measure it, all right, but the measurement is not given in a specific direction. For instance, you can measure the temperature of water, but it's not unlike, okay, the temperature of water is 20 degrees to the left or 20 degrees to the right. Okay, so there are some things you can only take the measurements, but they don't have any specific direction. So any quantity that can be measured but does not have a direction, all right, is what we refer to as a scalar quantity. And on the other hand, a quantity that can be measured that has, okay, which means we can measure it, it has a numerical value, but it also has direction. That kind of measurement is called the vector quantity. So while measurements like quantities like temperature, mass, time, all of those things like length, those set of measurements have magnitude, which means you can measure it and take the value of that measurement, all right, but they don't have direction. So because of that, we call them scalar quantities. But the ones that have both magnitude and direction are called vector quantities. Example of vector quantities, weight, right? My weight, like the weight of my body acts downward according to the direction of gravity. You understand that? So then force is also a vector quantity, because whenever you apply force on a body, you apply the force in a given direction. All right, you are either pulling something or you are pushing something with some amount of force. So that also is a vector quantity, because you can measure the amount of force you applied on an object, and then that force is always being applied in a specific direction. All right, you get that? So that makes force an example of a vector quantity. Another example of vector quantity is acceleration. Acceleration actually talks about the rate at which a change in velocity occurs. Okay, you are moving with a velocity of a particular value, and then you applied force to increase the velocity. All right, within a particular time frame. Okay, so that's rate of change of velocity, or the change in velocity in a specific time, is what we call acceleration. So because acceleration cannot occur without applying force, and that is what makes acceleration a vector quantity, because it involves force, and that force is being applied in a specific direction. All right, so we have other examples. Even velocity too itself is a vector quantity. Why is velocity a vector quantity? Because velocity itself is defined as displacements per unit time, that is, or rates of change of displacements, right? Physics makes us to understand that there is a difference between displacement and distance. Distance just talks about the difference between 2 points. All right, so the distance between here and here, all right, is just like the length between 2 points. Okay, the 2 point might not be a straight line, that can be curved and all of that, but then the fact that we measure the length between 2 points, that one is distance. But then when you talk about displacement is also a measurement of distance, all right, but in its own case is a measurement of distance traveled in a specific direction. You get that? So displacement is distance traveled in a specific direction, while distance is just the length between 2 points. Okay, so distance, then that's why you say, because velocity depends on displacement. That's the reason why velocity is a vector quantity, because the displacement in which velocity depends, it's a measure of distance traveled in a specific direction, so it has direction. You understand it now? So I don't want to go too much into physics, okay? So when we want to do physics, we'll talk more about all of these things. I'm just trying to make you understand that anything that can be measured and the thing has direction, that thing is a vector quantity. But if it can be measured but with no specific direction, then it's a scalar quantity. All right? And so that brings us to the end of this video. I hope to see you in the next video where we talk more about vectors. All right, bye.